Hello my dear students, this video is a part of partial differential equations series. In the previous lecture, we learned to form partial differential equations by elimination of arbitrary constants from a given function. In this lecture, we are going to learn how to eliminate an arbitrary function to obtain a partial differential equation from a given equation or function. Right. So let us see elimination of arbitrary functions. Elimination of arbitrary function. Suppose we are given a function like z equal to f of u. Z equal to f of u. What is u here? U is a function of x comma y. U is a function of x and y. Now f is the arbitrary function here. We have to eliminate this f. So how to eliminate? The concept is differentiate the given equation by x partially. What we get? So here the main important concept here is z is actually equal to f. F is a function of u. F is a function of u and u is a function of x and y. F is a function of u and u is a function of x and y. We are differentiating z with respect to x means we are differentiating f with respect to x. So how to differentiate f with respect to x? Because how to do dou f by dou u or df by du? Because f is a single variable function. F of u, right? U is a one variable. So f is a one variable function. So whenever you have one variable function, it is df by du. If f is a one variable function, it is df by du. If we have two variable function, we use dou, partial derivative. You will get partial differentiation, right? So f is a one variable function. So df by du multiplied by dou u by dou x. So in a series, it is multiplication. In parallel, it is addition. If it is parallel, it is addition. It is series, it is multiplication. So to differentiate f with respect to x, first we differentiate f with respect to u and then multiplied by u with respect to x. So it is df by du multiplied by dou u by dou x. Right? F is a one variable function, so df by du multiplied by dou u by dou x because u is a two variable function. Right? So similarly, you can differentiate with respect to y. You can differentiate this equation 1 with respect to y. What we get? Dou z by dou y equal to df by du multiplied by dou u by dou y. Dou u by dou y. Right? Now how to eliminate the function f from 1 to 3? Now you got two more equations, right? So from these three equations, 1, 2, 3, if you can eliminate f, that is elimination of f, you will result a partial differential equation. See, if you divide these two equations, 2 divided by 3 gives, so what is dou z by dou x? P. This is q. So P by q is dou u by dou x divided by dou u by dou y. Because df by du is cancelled and in this you do not have any f. So that is how sometimes we take the help of the given equation 1 also to eliminate the function f. So that is the procedure to eliminate the arbitrary function present in the given equation. Right? Let us take a problem z equal to f of x square minus y square. So here z equal to f of, this is in the form of z equal to f of u. F u. So you can write it as f of u, where u equal to x square minus y square, right? So u is a function of two variables x and y. So differentiate this equation with respect to x. We get dou z by dou x df by du, that means f dash u. Df by du is f dash of u multiplied by dou u by dou x. So if you simplify this, what you get? Dou z by dou x is p equal to f dash of u multiplied by, what is dou u by dou x? It is 2x. So this is equation number 2. Now you differentiate equation 1 with respect to y. What you will get? Dou z by dou y equal to derivative of f of u is f dash u into dou u by dou y. So dou z by dou y is q, f dash u multiplied by dou u by dou y. What is dou u by dou y? With respect to y, if you differentiate, x square derivative is 0 minus 2y. This is equation number 3. Now equation 2 divided by 3 gives p by q equal to f dash u into 2x by f dash u into minus 2y. So f dash u gets cancelled, minus x by y. Therefore py plus qx equal to 0 is the required partial differential equation. Right? Let us take another problem. X plus y plus z equal to f of x square plus y square plus z square. Now you can write it as f of u. What is u here? U is x square plus y square plus z square. Remember, here z is always, in partial differentiation, z is always a function of x and y. Z is always a function of x and y. It is dependent variable. Z is a dependent variable. X and y are independent variables. So now differentiate. See, this is somewhat different problem compared to the previous one, because here z is f. F is a function of u. U is a function of x. U is a function of xyz. See, u is a function of xyz. You have all three variables here, not simply x and y. So x, y, z is also there. But what is z? Z is a function of x and y. Z in turn again a function of x and y. Right? So if you differentiate equation 1 with respect to x, means what? Here it is 1, derivative of x 1. There is no x here. You have a x here because z is a function of x. So dou z by dou x equal to, what is derivative of f of u? F dash u. Now you are differentiating right hand side with respect to x. So what do you mean by differentiating f with respect to x? How many places or how many branches you have x? This is one branch, right? F u x. You have another branch f u z x. F u z x. So you can differentiate f with respect to x. When you are differentiating f of u with respect to x, it means df by du, that is f dash u multiplied by dou u by dou x. Right? This is in series. but you have another path is there, plus again f dash u into dou u by dou z, because u is a multivariable function, so dou u by dou z. First differentiate u with respect to z into again dou z by dou x. Right? Here you have how many places x you have, how many paths? There is one path to reach x. The path is fu x, fu z x. Derivative of f with respect to u multiplied by dou u by dou x. Plus, this is another path. So, plus dou f by or df by du multiplied by dou u by dou z multiplied by dou z by dou x, because u and z are multivariable functions. So 1 plus p, this is dou z by dou x is p, is f dash u you can take common, dou u by dou x plus dou u by dou z multiplied by dou z by dou x is again p. This is f dash u multiplied by, what is dou u by dou x? Dou u by dou x is your differentiate. Now the most important thing here is you should not combine, and that means you should not differentiate, you should not take z as a function of x and y while you are differentiating u with respect to x. See, this is purely differentiating u with respect to x only, right? So it is 2x, that's it, 2x plus 0 plus 0. Here you have to see you have to see u as a function of x alone, right? Because you are already taking or considering differentiating u with respect to z separately. So you should not consider differentiating z here in this first particular term. So it is dou u by dou z. Dou u by dou z. What is dou u by dou z? You differentiate u with respect to z is 2z into p. Right? Now this is one equation. Second one. Similarly, we get 1 plus q. When you differentiate equation 1 with respect to y, 0 plus 1 plus q equal to f dash u into dou u by dou y, because we are differentiating with respect to y, right? In place of x, you will get y. Dou u by dou z multiplied by dou u by dou z multiplied by dou z by dou y, which is q. Dou z by dou y is q. Here you have dou u by dou x, dou u by dou y, dou u by dou z, p, q. Right? Now this is f dash u into, this is dou u by dou y is 2y, dou u by dou z is 2z multiplied by q. Now if you differentiate or if you divide equation 2 and 3, f dash u gets cancelled and f is eliminated. Right? You need not take the help of the first equation. So 1 plus p, that means equation 2 divided by 3 gives 1 plus p divided by 1 plus q, f dash u into x plus zp into 2, f dash u into y plus zq into 2. You can take 2 also common, which is x plus zp by y plus zq. Now you cross multiply, you will get 1 plus p into y plus zq equal to 1 plus q into x plus zp. So it is y plus zq plus py plus zpq. And LHS. On RHS, it is x plus xq plus zp plus zpq. Zpq gets cancelled. Right. Now you take common p because we are going to form the partial differential equation. Right. Here we write in general some function of x and y into p plus some function of x and y into q equal to some function of x and y. So p and q are important here. So you take py, zp is here. You take both on one side, it is y minus z into p plus, and you take xq on the left hand side, zq. It is z minus x into q. So remaining is right hand side x, we have left hand side y. So this is the required equation, partial differential equation. This is the solution. Let us take another problem. Z equal to y into f of y by x. Y into f of y by x. So you can write it as y into f of u, where u is y by x. Here again f is a function of u is a function of x and y. U is a function of x and y alone. Right. So differentiate equation 1. Differentiate equation 1 with respect to x. It is dou z by dou x equal to, because we are differentiating with respect to x, y is kept constant. There is no x in this. So you can keep it as a constant and differentiate f of u with respect to x. So it is f dash u into dou u by dou x. F dash u into dou u by dou x. So it is y into f dash u. What is dou u by dou x? Dou u by dou x is y by dou by dou x of y by x. Y is constant. So dou by dou x of 1 by x. So y is a constant, you can take it out. So it is y into dou by dou x of 1 by x is minus 1 by x square. So it is minus y by x square. So therefore we got p equal to minus y square by x square into f dash of u. This is equation number 2. Now differentiate equation 1 with respect to y. It is dou z by dou y equal to, now we are differentiating with respect to y, right? And you have, this is the product of two functions. One function is y, another function is f of u, right? And both the functions have both the functions have y, right? So you have to go for uv formula. So y into derivative of f of u with respect to y is f dash u into dou u by dou y plus f of u into derivative of y with respect to y is 1. So it is y into f dash of u into, what is dou u by dou y? Dou u by dou y is dou by dou y of y by x. Now we are differentiating with respect to y. And 1 by x is a constant, you can take it out. Dou by dou y of y is 1. 1 by x. So it is 1 by x plus f of u. So it is q equal to y by x into f dash u plus f of u. This is equation number 3. Now, our aim is to eliminate f, right, from equations 1 to 3. Normally, f dash is eliminated or f is eliminated from equation 2 and 3 usually. And but if you take f of u to the left hand side and divide, f dash u gets cancelled. But you cannot eliminate f, right? For that, we have to take the help of equation 1. So therefore, this can be written as q minus f of u equal to y by x into f dash u, right? So you name it as 3. This equation is 3. Now 2 divided by 3, equation 2 divided by 3 gives p by q minus f of u equal to minus y square by x square f dash u by y by x f dash u. So these two gets cancelled, minus, so we have 1 y by x. So xp equal to minus yq plus y into f of u. See, still f is there in this equation, still it is to be eliminated. For that, we take the help of the first equation, where f of u equal to z by y. So from equation 1, you can write f of u as z by y. That we replace it here, minus yq plus y into z by y. Or y into f of u you can replace. Y into f of u is z. In place of y into f of u, you can write z. Both are same. Minus yq plus z. So therefore, what is the ultimate equation? xp plus yq equal to z. xp plus yq equal to z. So this is the required partial differential equation. Now take another problem. Z equal to f of sin x plus cos y. Sin x plus cos y. You can name it as, or you can take it as f of u, where u is a function of x and y is given by sin x plus cos y. So f is a function of u is a function of x and y. So differentiate equation 1 with respect to x, it is dou z by dou x equal to f dash u into dou u by dou x, which is f dash u into, what is dou u by dou x? We are differentiating u with respect to x. You have x here, so sin x derivative is cos x, and derivative of cos y is 0 because there is no x in that. So p equal to cos x into f dash u. This is the equation number 2. Name it as equation number 2. And differentiate equation 1 with respect to y, we have f dash u into dou u by dou y. F dash u into dou u by dou y. It is f dash u into dou u by dou y. What is dou u by dou y? Differentiate u with respect to y. There is no y in this, 0. You have y here. Derivative of cos y is minus sin y. So it is minus sin y into f dash u. Now divide equation 2 by 3. What you will get? Here it is P by Q equal to cos x into f dash u by minus sin y into f dash u. As usual, f dash u gets cancelled. This implies minus sin y into p equal to p cos x, q cos x. Sorry. So it is p sin y plus q cos x equal to 0 is the required partial differential equation. Let us take another problem. This problem is somewhat difficult and somewhat different. E power ax plus by into f of ax minus by. Right. So it is e power ax plus by into f of u you can write, where u is ax minus by. So again differentiate equation 1 with respect to x. It is dou z by dou x. Now we are differentiating this with respect to x, right? So we have x in this function and in this function also. So we have to go for uv. First function and second function both have x. So u into, that means e power ax plus by into derivative of f of u with respect to x is f dash u into dou u by dou x plus f of u into derivative of e power ax plus by with respect to x, dou by dou x of e power ax plus by. Yeah, differentiating exponential function. Derivative of e power x is e power x. So e power something is e power something again. Derivative of e power something is e power something again, multiplied by inner derivative of ax plus by with respect to x. With respect to x, right? So what is derivative of ax plus by with respect to x? A into 1 plus 0, a. E power ax plus by. That you have to write here, a into e power ax plus by. And e power ax plus by you can take common in both. F dash u into, what is dou u by dou x? Dou u by dou x is a into 1 minus 0, a. A into f dash u plus a into f of u. That means you can also take a out of this. F dash u plus f of u we got. This is P. Similarly, differentiate equation 1, you name it as 2. Differentiate equation 1 with respect to y, dou z by dou y is again e power ax plus by into derivative of f of u with respect to y is dou u by, that we f dash u into dou u by dou y. F dash u into dou u by dou y plus f of u into derivative of e power ax plus by. F of u into derivative of e power ax plus by with respect to what? Y here, not x. E power ax plus by with respect to y. What is derivative of e power ax plus by? E power ax plus by. And So what is derivative of e power ax plus by with respect to y? E power something derivative is e power something. So e power ax plus by into derivative of ax plus by with respect to y alone. Y. Right? We are differentiating with respect to y. So e power ax plus by into, with respect to y we are differentiating. So there is no y here, 0 plus b into 1, b. So it is b. b into e power ax plus by. So now you can take e power ax plus by common. F dash u into, what is dou u by dou y? What is dou u by dou y? When you differentiate u with respect to y, we are differentiating with respect to y, so there is no y here, 0 minus b into derivative of y is 1. So it is minus b, right? So it is minus b plus b into f of u. You can also take b out, e power ax plus by into f dash u minus f dash u plus f of u. You name it as equation 3. Name it as equation 3. This is q. Now how to eliminate f from these three equations? Right? That is very important. So the thing is, if you add these two, you will get p plus q. And if you add these two equations, 2 and 3, you cannot have f dash u gets cancelled, right? Because you have to multiply this by, because you have a here, you have b here, you have to multiply this by b, multiply this by a, and then add, f dash u gets cancelled, right? So that is how you can eliminate f dash u, so that you will get a f of u. And then you write that f of u back into the given equation, you will get the answer. You need not eliminate or you need not subtract this to find out f of u, right? So equation 2 into, here you have a, so multiply it by b, and plus equation 3 into a gives, it gives bp plus aq equal to, it is ab e power ax plus by into f dash u plus f of u plus ab e power ax plus by into minus f dash u plus f of u. You take ab e power ax plus by common, f dash u gets cancelled and we get 2 into f of u. So from this we got f of u equal to, or e power ax plus by into f of u also you can write, because e power ax plus by into f of u we need. That also you can write, or directly you can find f of u and substitute back into this equation 1. So f of u equal to bp plus aq, bp plus aq divided by ab, 2 is also there, 2ab into e power ax plus by. Now this name it as 4, substitute equation 4, or substitute f of u from equation 4 into equation 1, you will get the answer. Let us see. So what is equation 1? Z equal to e power ax plus by into f of u. E power ax plus by into What is f of u? bp plus aq by 2ab into e power ax plus by. This gets cancelled. bp plus aq by 2ab. So you cross multiply it, 2abz equal to bp plus aq. The required partial differential equation after elimination of f. Now the next concept that is somewhat difficult or next level in elimination of arbitrary functions is elimination of two arbitrary functions. Elimination of two arbitrary functions. See, because there are two arbitrary functions, usually we get second order partial differential equation as a solution, right? We will obtain or we will form second order partial differential equation here because we are eliminating two arbitrary functions. Before this, we eliminated one arbitrary function and we obtained first order partial differential equations where we have only p, q. In second order partial differential equations, we will have RST. We may have RST, any one of them at least. Okay. For example, let us take directly we go to a problem because there is nothing new in this. Just we take two functions in place of one. F of x plus at plus g of x minus at. Right. See, now this you can write it as f of u plus g of v z equal to, right? That means z is a function of f and g. Z is a function of f and g. F is a function of xy, g is also a function of xy. So here you have x and t. Because it is given t, you can write t here. Now, differentiating the given equation with respect to x, dou z by dou x equal to, now differentiate this directly with respect to x because we are differentiating x, z with respect to x. So differentiating this with respect to x is f dash u into dou u by dou x plus g dash u, g dash v into dou v by dou x. Right? See, f dash u into dou u by dou x, inner derivative of u. Here the inner function is v, so dou v by dou x. That's it. So which is f dash u. What is dou u by dou x? This is u. U is x plus at. So dou u by dou x is 1 plus g dash v into dou v by dou x. What is v? V is x minus at. So dou v by dou x is also 1 minus 0, 1. So it is f dash u plus g dash v. So remember, we are going to, or we will get a second order partial differential equation, right? Keep it in mind. So it may be necessary to differentiate this again with respect to x or y, because to get a second order partial derivative, right? So give some gap. Normally what we do, differentiate this with respect to t. The second independent variable is t, not y here. Dou z by dou t is f dash u into dou u by dou t plus g dash v into dou v by dou t. This is f dash u into, what is dou u by dou t? 0 plus a into 1, a. G dash v into dou v by dou t, 0 minus a into 1, minus a. So a into f dash u minus g dash v. Right. So even though you multiply this one by a and add, g dash will be cancelled, but f dash u will be there. That we cannot eliminate either using this or this. Here you have f, here you have f dash. If you eliminate f dash u, there will be g dash. That also we cannot eliminate. Right? And see, one time you differentiate this v with respect to t, you will get minus a. Another time you differentiate this again, you will get minus a again, so that minus a into minus a plus a square, so that you will get f dash u plus g dash v again here. Right? How to get a positive sign here? You differentiate this again with respect to t, you will get a positive sign here. Right? Let us see. Now this is, differentiate this with respect to x again, dou square z by dou x square is f double dash u into dou u by dou x plus g double dash v into dou v by dou x. Right? So what is f double dash, what is dou u by dou x? Dou u by dou x is already 1. So it is f double dash u plus g double dash v. Here you differentiate this again with respect to t, dou square z by dou t square is a into f double dash u into dou u by dou t minus g double dash v into dou v by dou t. This is a into, what is dou u by dou t? Dou u by dou t is a, dou v by dou t is minus a. So dou u by dou t is a into f double dash u plus g double dash u in v into dou v by dou t is minus a. So you will get a, so you have negative sign here, so that you will get minus into minus plus here, and you can take a out, a square into f double dash u plus g double dash v. So this you name it as third equation, this you name it as second equation. You see, now this is f double dash u plus g double dash v, f double dash u plus g double dash v. So that simply you divide these two, equation 2 and 3, f and g will be eliminated. So here I write the answer. It is equation 2 divided by equation 3 gives dou square z by dou x square by dou square z by dou t square equal to f double dash u plus g double dash v by a square into f double dash u plus g double dash v. So it is 1 by a square. So what is the answer? Finally the answer is a square dou square z by dou x square equal to dou square z by dou t square is the required answer. Now let us take one more problem. Z equal to y into f of x plus x into g of y plus x into g of y. So this looks very simple, but it is very difficult and somewhat difficult and a very important problem. Okay. Now differentiate equation 1 with respect to x. It is dou z by dou x. We are differentiating with respect to x and y is kept constant. It is f dash x. Right? Simply derivative of f of x is f dash x. Plus here you have g of y is constant because there is no x in g of y, into derivative of x with respect to x is 1. So it is y into f dash x plus g of y. Now differentiate equation 1 with respect to y. Here you have f of x is constant, derivative of y with respect to y is 1. Differentiating with respect to y, so x is constant, g dash y. So f of x plus x g dash y. Right. Now how to eliminate f and g from these three? It is not sufficient, right? These equations are not sufficient to eliminate f and g comfortably, right? Forming another equation like either dou square z by dou x square or dou square z by dou y square or dou square z by dou x dou y. Let us try dou square z by dou x dou y. Differentiate this equation with respect to y, dou by dou y of dou z by dou x. So dou by dou y of y into f dash x plus g of y. Right? Both sides differentiate with respect to y. Now we have y here, f dash x into derivative of y is 1. F dash x is constant because we are differentiating with respect to y, plus derivative of g of y with respect to y is g dash y. See now, we have, this is nothing but dou square z by dou x dou y. Dou square z by dou x dou y is f dash x plus g dash x. Now you can obtain same f dash x plus g dash x from this also, right? You can differentiate this equation with respect to x, but both are same, no? Dou square z by dou y dou x you will get the same f dash x plus g dash y you will get, but LHS and RHS are same, right? So here also you will not get any partial differential equation. Then how to eliminate f and g from these two equations? So this differentiating second equation by x will not help us in any way, because we are getting the same equation again, right? Because dou square z by dou x dou y is same as dou square z by dou y dou x. LHS are also same, RHS is also same. So we have to use this equation, this and this to eliminate f and g. So how to eliminate f and g, right? So from this equation, what is this first equation? The first equation is p equal to y into f dash x plus g of y. This equation is q equal to f of x plus x into g dash y. And this third equation is, this is yes, right, PQRST, RST. R is dou square z by dou x square, S is dou square z by dou x dou y, T is dou square z by dou y square. This is the standard notation, right? So that is how it is. This becomes S equal to f dash x plus g dash y. So from these three equations, we eliminate f dash. How to eliminate f dash? From this you write f dash, right? So therefore P equal to y f dash of x plus g of y implies f dash of x equal to p minus g of y by y. Similarly, from this you eliminate g dash. It is g dash q equal to f of x plus x g dash y. Implies g dash y is q minus f of x by x. Now you replace both f dash and g dash in the fourth equation. So therefore s equal to p minus g of y by y plus q minus f of x by x. So you cross multiply, you will get xy in the denominator, LCM xp minus xg of y plus yq minus y into f of x. So it is, you can take this xy to the left hand side, cross multiplication, xys you will get. xp plus yq minus of, you take minus common, what you will get? X into g of y plus y into f of x. So it is xp plus yq minus, what is x into g of y plus y into g of f of x? It is z minus z. So xys equal to xp plus yq minus z, right? So that is the required partial differential equation. Now we have another type of equations, elimination of capital F from equations of the form f of uv equal to 0. F of uv equal to 0. So for this kind of equations, here what is f? F is a function of uv, u is a function of xyz, v is a function of xyz, and z is again a function of xy. Right? So differentiate this equation both sides with respect to x, equation 1. So what you will get? How to differentiate this with respect to x? Differentiate f with respect to, where is x? You have in 4 branches. Here you have x, here you have x, right? And here you have x, here you have another x. So you will get 4 terms. Dou f by dou u, because f is a 2 variable function, you will get dou f by dou u into dou u by dou x plus dou f by dou u into dou u by dou z into dou z by dou x. Dou f by dou u into dou u by dou z into dou z by dou x. This is all differentiating f with respect to xy in this branch. You have another branch, plus you can also differentiate f with respect to v multiplied by dou v by dou x, because here also you have x, plus dou f by dou v into dou v by dou z into dou z by dou x equal to 0. So this you can write as dou f by dou u, you can take common, dou u by dou x plus dou u by dou z into dou z by dou x, right? You can take this right hand side, it is minus dou f by dou v into dou f by dou v, you can take common, dou v by dou x plus dou v by dou z into dou z by dou x. You name it as equation 2. Similarly, if you differentiate the given equation by with respect to y, this is with respect to x, right? Here with respect to y, differentiate this with respect to y on both sides, you will get dou f by dou u into, everywhere you will get y instead of x. Dou u by dou x plus dou u by dou z into dou z by dou y. Minus dou f by dou v into dou v by dou y. Sorry, here also you will get y. Right? Wherever you have x, you will get y. Plus dou v by dou z into dou z by dou y. You name it as equation number 3. See, now differentiate or divide equation 2 by 3. You will get dou f by dou f, dou f by dou u, dou f by dou u gets cancelled on LHS, and you will get dou u by dou x plus dou u by dou z into dou z by dou x by dou u by dou y plus dou u by dou z into dou z by dou y equal to, again these two are gets cancelled, so minus minus also gone, dou v by dou x plus dou v by dou z into dou z by dou x by dou v by dou y plus dou v by dou z into dou z by dou y. So there is no capital F in this, so we have successfully eliminated capital F, right? The arbitrary function f we eliminated, and you simplify this, you will get the answer. And we are eliminating only one arbitrary function f, so that you will get a first order partial differential equation. Even though it looks very complicated, it is a first order partial differential equation, because what is dou z by dou x? It is p q. It is p q, right? Now we will solve some problems in this method. Let us take f of xy plus z square, xy plus z square, x plus y plus z. So this is in the form of f of uv equal to 0, where u is xy plus z square, v is x plus y plus z. So what we have to do is differentiate this with respect to x on both sides. What we will get? Dou f by dou x, so dou f by dou u, dou f by dou u into dou u by dou x plus dou u by dou z into dou z by dou x. Right? You remember the equations that we just wrote in the previous explanation, right? Equal to minus of dou f by dou v into dou v by dou x plus dou v by dou z into dou z by dou x. So this is, you can also write f suffix u. What is f suffix u? It is dou f by dou u simply. F suffix v is dou f by dou v. Ux, differentiate u with respect to x. It is purely, here what you have to remember, I already told you in the previous problem. Here you have to remember, in this we are differentiating u purely with respect to x, right? U with respect to x only. Even though z is a function of x, you should not differentiate, because that is considered separately. Differentiating u with respect to z and then z by x is considered separately. So we are differentiating u with respect to x alone. So treat it as a all three variables x, y, z as a independent variables and do it, right? So differentiating u with respect to x is y. derivative of y into derivative of x is 1 plus 0 plus differentiate u with respect to z is 2z into p equal to minus fv. Differentiate v with respect to x 1, v with respect to z 1 into dou z by dou x is p. Similarly, if you differentiate this equation with respect to y, what you will get? Fu into dou u by dou y. You will get dou u by dou y. Differentiate this with respect to y, x, plus dou u by dou z is 2z into dou u by dou z by dou y, q. Dou z by dou y is q minus fv 1 plus 1 into q you will get. So divide these two equations. 2 divided by 3 gives y plus 2zp by x plus 2zq is 1 plus p by 1 plus q. 1 plus q into y plus 2zp is 1 plus p into x plus 2zq. So y plus 2zp plus qy plus 2zpq, x plus 2zq plus xp plus 2zpq. 2zpq gets cancelled and you take 2zp xp. You take one side, it is 2z minus x into p, qy z 2zq. So it is y minus 2z into q equal to x. You take this y to the right hand side, it is minus y. So this is the required partial differential equation of first order. Now let us take one more problem, last problem of this lecture. F of z by x square comma x minus y equal to 0. So you can write it as f of uv equal to 0. U is z by x square, v is x minus y. V is x minus y. And differentiate equation 1 with respect to x, fu, differentiate f with respect to u into ux, differentiate u with respect to x plus uz into zx and dou u by dou x, right, equal to minus fv, v, differentiate f with respect to v into vx plus dou v by dou z, which is vz, into dou z by dou x p. Right. Similarly, you have fu differentiating with respect to y, with respect to x, with respect to y. Dou f by dou u, uy plus uz into q minus fv, vy plus vz into q, vz into q. So from this first equation, what we get? Fu into, what is ux? Dou u by dou x. Dou u by dou x. U is z by x square. Dou by dou x. Dou u by dou x is dou by dou x of z by x square. Differentiating z by x square with respect to xl1 is, you can take z out because it is treated as a constant here. Dou by dou x of 1 by x square, z into minus 2 by x cube, right? Minus 2 by x cube, minus 2z by x cube, that you write here, minus 2z by x cube, plus dou u by dou z. Differentiate u with respect to z. Dou u by dou z is dou by dou z of z by x square. So 1 by x square is constant here. 1 by x square comes out. Dou by dou z of z1. So it is 1 by x square into p divided by fu into uy with respect to y. We are differentiating. There is no y directly here. 0. uz is same, 1 by x square, and same q have here, minus fv. Vx, differentiate v with respect to x is 1. Vz, dou v by dou z. Dou v by dou z is 0 by minus fv. Vy, differentiate y, v with respect to y is minus 1. 0 minus 1 minus 1. Right? Plus vz is 0. 0 into q, 0. So these two gets cancelled. Minus 2z by x cube, if you take LCM, it is xp by q by x square. It is minus minus 1, it is minus 1. So minus 2z plus xp by x cube is minus q by x square. So you will get minus 2z plus xp equal to minus x cube, minus x cube. So you take this to this side, xp plus x cube equal to 2z is the required partial differential equation. So this is all about eliminating arbitrary functions. Eliminating arbitrary functions. If you eliminate one arbitrary function, you will get first order equation. Eliminate two arbitrary functions, you will get a second order. Like that, you may be having higher order also, if you want to eliminate more number of arbitrary functions. Okay, thank you. In the next class, we will try to solve partial differential equations. Right. Solving partial differential equation is nothing but finding this function when this equation is given. Formation is, when this function is given, we are obtaining a partial differential equation is formation of a partial differential equation. The reverse process is finding this function when this equation, partial differential equation, is given. That is what solving a partial differential equations. We will learn in the next class. Thank you so much.